This conference will now be recorded.
Right. For MongoDBs, guys, the Mongo replica set and sharding, these are the two big technologies which will add up a lot of weight to your resumes. So we're going to see in and out of it, what exactly, how exactly, and what type of different things we have. We're going to spend quite a long time on these two technologies, especially. Why? Because of the amount of weightage for these two technologies that you have as a DBA, and you need to know if you are trying, if your company supporting or you're supporting this technology, you need to know in and out of the background as well as theoretically, architecturally, everything. So we'll spend quite amount of time on this one, especially focus on these technologies to become a core advanced DB, especially. Right. So a replica set. So let me anything like before I talk with the slides, I just wanted to make you understand what it is diagrammatically. I'll give a fair idea how it works on all discussions. Then I'll open the slides. The slides will become dead simple when you understand this. Basically, we'll call it as replica set. Basically, so minimum we'll go with the three servers with the replica set. Minimum three mandatory. Why it is three? Why don't we go with two? I'll explain all of that. So, like every server will have, of course, your data will be modified in the memory, and your data first will be written to the journal. From journal, it will get hardened to the data file. Right, this is the usual that we discussed in the architecture in the beginning itself. First, all transactions at server level will get recorded on the journal. Then it will go to the data files, basically. That's how the data manipulations will happen in Mongo, right? So all will follow in the background, same thing. And there's some special collection it will create under local database called oplog. This is one of the important component of replication. You need to understand how it is going to work. I'm going to talk about in and out of it. I don't leave anything behind for this technology. This is such an important technology, basically. So we'll have the terms called primary replica, primary member, okay, and secondary, and this is another secondary we are going to keep. I'm going to discuss a lot of situations with this. Once you understand, then we'll go with the slides anyway. So if I have to name it, just I'll name it memory. This is a memory, okay, where everything will take place. This is a journal where all primarily will be applied to the journal first, then to data file. This is the data where actual data is sitting. Okay, this is called oplog, and this is one which actually does like a replication in the background. And you will have the application always hit the primary for all operations as long as you don't keep the for secondary configuration. How we can read from the secondaries only, that's something we have to set at connection level. The connection will take care of that. And you have a URI, you call all the servers together. By default it will hit the primary. You want it to prefer, it will by default hit the secondary only. We have the connection string, we're going to see that. First try to follow this for now. This is an application. So MongoDB by nature, we discussed all of that, guys. From journal data, how frequently data will get written? 60 seconds or 2 GB of data when it is fills in the journal. Checkpoint case we discussed already. 60 seconds or 2 GB. You guys remember, I guess we spent on this a lot of time. So when data will get the data when it is 60 seconds or 2 GB, whichever comes first, then the checkpoint will trigger and the data will get synced up. But from memory to journal, when it will get the data, every 50 milliseconds generally. The nature, it can be milliseconds, but millisecond means what? 1 second equal to
Ravi,
1000 milliseconds. Second we are talking about, it's not a minute. 1 second equal to. Mhm.
there is a disturbance in your voice. So
Yeah,
what you there is a disturbance in your voice. So you initially what you explained for 60 seconds or 2 GB. After that, we missed couple seconds.
oh, is it so? Is it clear now?
Yeah, right now it's clear, but in between it's missing voice.
Okay, fine. Sorry. I'll repeat. Not See, guys, in Mongo replica set, at least 3 servers should be there. Thanks, Biran, for just updating because I wouldn't have noticed. Yeah. So here for replica set, Mongo replica set, minimum 3 servers are required for us. I want to give you the fair idea why we need three, why not two, why two can suffice the configuration kind of. Before it, what I'm trying to say, every machine will have a memory, right? Where the application will hit the data and get the data into memory, do the modification, all that. That modification first will record in the journal. Journal is like a log at server level. In Mongo, we don't have a database level log files. At the server level, all transactions, all changes that happens on the system first will record in the journal. Everything on all databases, all collections, irrespective of the everything, just journal. You don't have a separate file where it logs. Every 50 milliseconds generally, it will write all of its content, modified content, dirty data into journal. Then it'll give a confirmation to the application generally. It has to write in the journal. Then application would get the confirmation journal. That's how things goes in the background. In case of Mongo, all of a sudden abruptly restarts, it picks up the data in the journal and come online with all the gap. If something actually, if it restarts, that we already discussed. So now there is something, a new mechanism will come into picture here. The new mechanism is oplog. Oplog exactly what it does. Whenever it is writing the data to the journal, when you enable the oplog, when you enable the replica set on the particular machine, it will create the oplog by default. That is the nature of Mongo. By default, it will create the oplog. It will write the data into journal as well as into the oplog. Simultaneous action. Simultaneous action. It writes into journal and replica set basically. So in every machine, you follow the same thing. Like it will come to the memory, then journal, oplog, and data. Memory, oplog, data. Like that, it will go on. So, but here the changes only will take place in the primary, and the secondaries are only the standby. It will sync from here and here. Okay. No, actually, this is responsible for sending to this. This is only responsible for sending to this one as well. It won't sync from the secondary again. This is how the data will transfer. So whenever the changes happens here, it immediately sync with the secondary member automatically. It's no need to ask. It's inbuilt function. It will go and sync with the next microsecond itself. Whenever it receives in the oplog, it will try to push that change into this oplog automatically. And then from here, this data will get updated in interval of 50 milliseconds or lesser than that. It depends on the system availability. As soon as the oplog is synced up from primary to secondary, data will be applied to the secondary server data directories basically here. Okay. So
In a
the
question,
main Mhm, mhm. Good.
so in secondary, it's not going to follow flow from memory to general.
No, no, no. It is only oplog. This is the only thing. No memory, no journal. It just goes through the oplog to oplog. Oplog is responsible. It's something is accumulated. All if example this is down, this will keep the data. At least depends on the size of the oplog. When it comes online, whatever the gap is there, it will pick up automatically. If example, I'll talk about all of this anyway. First, let's understand the architecture. So the sync will happen like this. Primary is responsible for writing all your data. Only one copy make one server. Copy means one server is actually allowed to write. The rest you can keep up to only readable. You can keep one primary, 49 secondaries. 49 total 50 Mongo instances you can keep in a single replica set. In a single replica set, We never do that, but that is a limitation. If someone asks you how many nodes we can add in a single replica set, 50. Is data level or what do you, it is server level. See, replica set, you don't have a choice to choose one database only I can replicate it kind of. When you enable the replica, it is by default server level. In Mongo, you don't have a database level replication. It is absolutely at server level. Whatever you have, byte by byte will reflect here. Everything that you have in the here, it is there here and here. There is no database level replication here. Complete server to server. That's it. You don't have an option in Mongo to just replicate one single database basically. We don't have that technology in Mongo. Like what we have in RDBMS replications, all object level, database level, server level, we have all that in Mongo. We don't have that. It is server to server itself. There is no option for us. And sharding is something, it's a complete distribution of data. That does not even talk about again object or database. It is complete server distribution of what you even sharding is a collection level. That is something we will see. I don't want to get into that side because you'll confuse now. First, understand the replication. Primary will receive all the write operations. It is simultaneously write into journal and oplog. From oplog, it will sync with the secondary oplog. We will see. I'll do the transaction. I'll do the entry. I'll show the entry here. The same entry will reflect here. Same entry will reflect here. Same data instantly available in these data directories, data files. I mean, we'll read data, everything in and out. First, we'll understand it. So now you can keep one primary in one replica set, no two primaries at all, and 49 can be possible. We don't do that, but there's a possibility of. Is my audio clear?
I think, yeah, now I see that there's a lag of few seconds, Ravi.
Just a minute, I'll get my mobile net. Maybe my internet giving me issue. Just a minute, I'll be back.
Now it's better.
1 minute, guys.
Sure.
Maybe my internet is not stable, it seems. So I'll switch the connection. The mobile. Can you hear me? I guess it won't be an interruption now onwards, I feel. Can you hear me, guys?
Yes, I can hear you.
Okay, good enough. Just let me know if you see that there is a lag. Maybe the Wi-Fi was having the issue. Okay, good enough. Okay, guys. So now there is something again. Out of these many machines, 50 machines, only 7 machines can involve into voting. See what happens in this case. Why we went with the three node? Why not two? Why not two are not sufficient basically? One primary, one secondary is enough, right? Why we go with two secondaries actually? You must go with the two secondary. The reason behind is there is a voting involved in the background when failure happens. If example, this primary is down, if this primary is down, it will fail over automatically to secondary. To second, one of the secondary to become primary, there is voting involved in the background. What kind of voting? Basically, n equal to n by 2 plus 1. It is mandatory to follow this voting. Then only a primary will be elected. So if it is 3, example, if it is 3, uh, one node goes down, then how many it will become? 2. 2 by 2 plus 1 equal to 2. So if you see 3 off is 1.5, 2 is greater than that. So I mean, if you see most, if example, if I have what I would say, if I have a 5 nodes, 5 nodes, 4 secondaries, 1 primary. If primary goes down, what happens basically? 4 by 2 plus 1. So in this case, what happens? 2 plus 1, 3. So it will sustain basically. So what exactly it mean? Whatever the value you have, make it off and plus 1. And that value, if it is satisfying, primary will be elected. If not, it won't elect basically. It is a rule. Example, if I have 7, at least 4 nodes to be available, then only the primary will be elected. At least 4 nodes should be live. Why? Because 7 of actually 3.5, it is more than that. It is more than that. See, try to understand this, guys. This election is very, very important to understand. If I have 3 nodes, I have only 2 nodes, assume a case. If one node goes down, only one node will be left behind. If one node left behind, no election, only the secondary will remain secondary only. It never become a primary. It need at least 2 votes to become a primary. It need minimum 2 votes to become, it's like a quorum. Even clustering also, Windows clustering, we have 2 node cluster, we'll have a quorum also. If quorum goes down, one of the node goes down, the other one will not take the ownership. That won't come online basically, because quorum lost, even the primary node also gone. So both if go gone, it will go to the, it will not come online basically. Okay, so the same thing here also, you need a voting. You need a voting to become a primary. To become a when primary goes down, secondary to become primary, it need this many votes basically. Okay, n by 2 plus 1 always should be satisfied to get that basically. So whenever we go with any configuration, we'll go with the odd nodes, 3, 5, 7, 9, 10, something like this. So 11. But anyway, I never seen going beyond 5 basically. 3 itself is a maximum. 99% people will follow the 3 node replica set, 1 primary, 2 secondaries. And one more thing is called arbiter. Arbiter is also very important. Everywhere, 90% of the people, one data set, one primary data, one secondary data, one is dummy data, dummy node, not data, dummy node, which will involve into voting to, if primary goes down, the primary secondary will become primary, because this is going to give a vote. We'll call it as arbiter node basically. Arbiter node does not hold the data at all. It's just a Mongo service which will add into the Mongo member as a member that will just vote, so that if primary goes down, one node will become a primary, because it is eligible to become a primary because it is receiving the 2 votes. You guys are trying to follow or confusing? Say something. This is important point.
It's confusing.
Right. See, first you need 3 nodes first. Why? Because you need a voting, majority of the voting. You have 3. You have 3 nodes. If you have only 2 nodes, assume a case, only 2 nodes you have it. If this formula has to be satisfied to become a primary. So if one node goes down, what happens? 1 by 2.5 plus 1. So 1.5. It is not satisfying the rule basically. It is not satisfying the rule because you have 2 nodes. 2 nodes is not divisible by 2 basically, right? Even if it is divisible, 0.5 plus 1, 1.5. 1.5 is actually not majority from 3. If you look at the better way, I'll explain directly. Without formula also we can explain. I can make you understand anyway without formula, but anyway formula will be followed in the background. See guys, you need, at whatever the situation, if I have a 7 nodes off is 3.5. If I have 4 nodes availability, I can get the primary elected. If it is 5 node replica, 3 should be online to get the election started, because it is 5 off of 5, 2.5, but 3 is higher than that basically. So you need to look at this direction. If you have 3 nodes, 2 nodes should be available. If it is 5 nodes, 3 nodes should be available. If it's 7 nodes, 4 nodes should be available to start the election. If not, Even you're keeping 7 nodes in the replica set, but 4 nodes are down, 3 nodes are alive, there is no election. All will remain as a secondary only. They don't start the election because they are not having the enough of voting. The number of nodes, the number of vote it is getting is lesser than the actual one. It is always required. You divide it by this thing, okay? It is 3.5. 3.5, and if you 3 nodes are down, if 3 nodes are down, it will become 4 nodes, right? Out of 7, 3 nodes are down, it will become 4. If 4 nodes are down, it will become 3. So this value is higher. Think in this direction. The formula, leave the formula behind and try to understand the actual node divided by 2 example 3.5. So if 3 nodes are gone out of 7, 4 it is becoming. This value is greater than this, so election will start. The same way, if it is 3 nodes case, 3 by 2 equivalent to how much? 1.5 if you divide. So how many nodes I need to have? At least a minimum 2 nodes should be available all the time. If it is a 5 by 2, if you look at it is 2.5. You keep in this way in your mind, it will absolutely become easy. So 3 nodes should be available to become a primary. 3 nodes should available to take the primary role, then only election will start. If not, election will not start. Does it make sense? If it is 7 by 2, okay, what is 7 by 2? 3.5. So how many nodes I need alive to start the election? 4. It's a 4 definitely should be there, then only election will start. If not, no election, all will become stay as a secondary only. No right operation can happen in that direction if that is the case. You guys following?
So
At
in
least you
simple
follow.
language, I think in simple language, more than half node should be available to bring
Exactly.
the.
That exactly. What you said is absolutely right statement. More than half. More than half means if you have 7, you need to have 4. If you have 5, you need to have 3. More than half. More than half of the servers you wanted. That is the best word she picked up, I would say. No confusion at all. More than half means one node extra. More than half, see one extra here, one extra or half extra, whatever it is. More than half. So off the 1.5 it is more, it is off 2.5 it is more, it is off 3.5 it is more. So it is available. That is the best word you picked up. Thanks for that. So now see here in the real world, let me conclude this. See, op log is something which is responsible for sending the data to secondaries. If one secondary is down, assume a case, one secondary is down and op log is holding, assume a case, 3 hours data, 3 hours modification it is holding, then it is flushing, it is capped collection. We, op log is a by default capped collection. It will depend on the amount of data disk size. Okay, if you have 100 GB in the data disk you have 100 GB, it will create 5 GB op log. If you have 1 TB in the op log, assume a case, 50 GB it can create, 50 GB op log, very big. There is a formula for this. Again, it's not something we can just I can make a word, I just write this exactly. Op log size. Op log size means this is the size we are talking about right now. Try to understand. This is another big point I'm making here to understand. Op log size depends on the size of the data drive. It is automatic. You don't control it. It is by default, by nature. You can change it if you want it. If you can change it if you want it. How do you change also? We'll see that. But by default, when you configure the replica set, it will configure the op log by default. You cannot configure. It will configure, but you can extend the size if you want it. But by default, how much space it will take?
5%.
This is about the memory, right? Op log size. This is about right. This is the one. This is one we are talking about. It is in memory. Then 50 MB it will start with. It will go up to 50 GB as a maximum. If it is a white tiger, it will take 990 MB by default. Op log size minimum is 990 MB. The maximum it can go up to 50 GB only. It cannot go beyond it. This is a maximum, this is a minimum. So example, assume a case. I have a 10 GB in the data directory. How much it will take? 5% of it first. 5%. See, default top lock size is 5% of your data disk space, data drive disk space. 10 GB, how much it will take? For a 1
half
GB, how much? 50 MB, right?
half GB.
No, half GB. How come? All right, half GB, right? 500 MB. You're correct. So 10 GB, 500 MB means it is not qualifying the minimum. So it will take 990 only. It's not something. If it is not for qualifying the minimum, it will take minimum. If I have only in our direction, oh, VM got shut down. Really? Just a minute, I'll quickly start. I mean, I'll just show it. I mean, we don't talk about any practical today. There is a lot of things you need to understand. Then I'll enter into practical. Tomorrow I'll start the practicals. For now, just try to understand this. If you understand, then I can talk all practicals. You can easily catch. You need to understand the background. I'll spend 3 more class on this one, on this, especially the replica set. Right, it is up. So if I go to the machine, if I see the disk file system, what I have, come on, where did we place the files? We place the files in the where. This is what your data directory. What is the capacity of this drive? This will look for this one, not the available one. It look for the capacity of the data drive of that Mongo. If it is a 6 GB, what is a 5%? 300 MB. 300 MB is not the case. It definitely have to pick up the 990 MB, the size of the oblong. It doesn't mean that it is going to occupy the 990 MB by default. No, it will capital collection size is 990 MB. Okay, then whatever the data is keep coming in the oblong, then it will occupy the actual storage at the back end. See, if I have 1 TB data directory, it will pick up a 50 GB by default. 1 TB means 1050. 5% of 150 is becomes a 50 GB. 50 GB is a maximum. If you are configuring, it is not going to occupy the 50 GB at OS level. It's just a capital collection up to 50 GB. As data is going to insert into the this oblog, then it will occupy the actual storage in the background. Following or not following? This statement is very important again. See, the oblong size is a minimum 990 MB. It's a minimum, irrespective of the size you have in the data drive. If you have 1 GB drive in the data directory, oblong itself is going to take 1 GB. You cannot configure the replication. You definitely need to have at least 6-7 GB in the data directory where you're trying to do. 6-7 is not required. At least 2 GB. 1 GB is given to this one. You are playing with a small data, which is fine. At least basically. So 990 MB is by default oblong size. Oblong does not occupy the storage directly from the OS side. As the data is keep loaded into the oblong if it is going to go up to 990 MB, then it will occupy the storage. It's just a capital collection. It can go up to that point. I'll show the all of this when we configure it anyway. Now, assume a case that this oblong is holding 3 hours data, and secondary is down. It came online after 3 hours 10 minutes. So what happens in this case? 3 hours data, after 3 hours data is flushing because it is capped already, and this has a 10 minutes gap. It never sync anymore. It will not take the data. Why? Because it knows till what point it is synced, and it has to know where it has to start as well. It knows internally. You don't need to worry. Mongo secondary will not pick up the data if there is any gap happened because of it went down too long. You have to sync manually if it goes out of sync. Very simple sync. Sync is very simple in Mongo, but you need to understand if oblong directory offlog how much data it is holding up. Within that time, secondary should come online. If secondary is not coming online, if some data, even 1 second data is flushed out without syncing, secondary will not pick up the data anymore. Why? Because the gap is, it knows gap is created and don't take the data. Even if I take the data, I don't make sense. I don't operate with the data gap. So you have to sync it manually. What are the possible ways we can sync it manually? We're going to see that situation to situation scenarios. I'll create a situation. I'll show you how it can be synced. We'll see that all of that. Lot of scenarios I'll run through. Especially two classes are practical. One is a configuration. Two more are only issues in the replica set. Roughly 3 hours issues we will talk about. Every issue will take 10 to 15 only. There are a lot of issues we have. So I'm going to pick up all possible issues that I faced in my career. Okay, because it's such an important technology, you need to know. So now I'll conclude this architecture first. We need a 3-member replica set. It is a minimum. One data, one secondary with the data. Third one can be arbiter, just an arbiter. Arbiter does not pick up the data. It does not pick up the data. Only it will just run as a MongoD and it will join as a member. It does not take the data. It will act like a voting member. Voting member means if primary goes down, this should become a primary. It will vote. Okay, I'm voting, you also vote one, so you get the majority of the vote and you become the primary. It is handing the primary role to the secondary by giving the vote. Arbiter means arbiter does not hold the data at all. It's just a member. It does not even receive the data. This is a famous configuration everywhere. See, we have roughly 60 to 70 production replica set servers. Production I'm talking about. 60 to 70 production Mongo replica sets we are running with the data. Only enterprise, if you take about, hardly we have 12 to 15 servers, production Mongo servers. We are running most of the infrastructure on the community edition because it is free. No, zero money. You don't need to pay anything as long as you're not going for the support. If you are going for support anyway, you have to pay, and we are subscribed for the support also for community edition. We are paying for the support to the MongoDB for community edition. We are saving the licensing cost. Licensing is little more costly than the support. So our clients prefer to have a community edition and get the support. Most of the time, we will only fix it 99%. In a month, also, in a overall year, we might talk to them or 5 or 6 times because of some product bug, because of it goes, a product itself is having some issue. Then we'll talk to them, we'll rectify them, we'll gain the knowledge out of them. That's how it is going to happen. In enterprise, some critical data, some enterprise clients are running. I mean, very critical data we are running on the enterprise, and enterprise will have a lot of automation, taking the database backups automatically, point in time recovery is fully automated, and monitoring. If anything goes down, you'll get an alerting, and encryption is available. So some major features are deprecated in the community edition. You don't get it. So only in enterprise you will get it. So critical data will go towards the enterprise side. Normal data you can operate with the community side. That's how. And everybody is looking in the market to save the money. When Mongo, see, community edition, enterprise edition wise, data wise, both are equally capable handling the data. Only the features are deprecating. So if you take about SQL Server, the capacity is actually standard edition to enterprise edition. There is a huge variation. Standard edition, you can pick up only 24 CPUs, 128 GB RAM. If it is enterprise, you can claim how many CPUs you have on the machine. 512 CPUs it will claim, and 1 TB RAM, 2 TB RAM it will pick up basically. So there is huge variation in terms of data handling. In MongoDB, there is no variation in terms of data handling except the features. Features in terms of monitoring, in terms of backups, in terms of encryption, in terms of all monitoring kind of. There are 4 or 5 features which are major for enterprise, especially for critical data. They are deprecated. But community edition as good as enterprise in terms of data handling, except these features. Okay, that is the reason replication is highly implemented, and to save the money everywhere. Anywhere you go, replica set is mandatory configuration. You may not see the sharding, but replication is mandatory for every production. Right. Anyway, let's move on. So
question.
this, yeah, go ahead.
Sorry.
Santosh.
So this replica set should have. Sorry, I'm trying to understand. It's like 3 servers, or it's kind of a cluster.
We don't say it is a cluster. It is a replica set basically. Either it is kind of a cluster only, you can say, in terms of RDBMS terminology. In NoSQL terminology, we don't say it as a cluster. Replica sets. Word we change it. Yes. If you take the like normal in terms of understanding RDBMS terms, it is a cluster. It is a cluster. If it is in RDBMS terminology, but in Mongo terminology, we don't say it as a cluster, only replica sets.
Three
Is it
servers
clear?
on the same, 3 nodes on the same server or
Yes.
something?
This is
Okay.
one node is one server. This is another node with a secondary. It's another node is another secondary. I mean, machines are separated, not in the same machine. All are different machines
Different machines.
and different, absolutely different. If one goes down, these physically both should be available. If you keep it primary and arbitrary in a single machine, if it goes down, one primary will become automatically secondary. There is something, if secondary is gone down, the arbitrary is also gone down, the primary automatically becomes secondary. There is no role, primary role, because there is no enough voting to to sustain as a primary. Primary no need to fail, even secondary fail, arbiter fail, or secondary data nodes fail, anything happen, only one left behind out of three. Even it is primary left behind at the end, that also will become secondary automatically, because it did not get the enough of voting to sustain as a primary. All the time, more than half votes should be given, then only the primary will sustain. If not, primary also will become secondary automatically. Following? Say something, I'll start the slides if you understood this.
Yes, Ravi, I'm following.
Everyone followed? If you have any question, please let me know. I'm absolutely okay to talk, because this is something important. Slides I can go through quickly. Why? Because all I have discussed, the same thing is there in the slides.
The oplog
Okay.
is logical separation or a physically it is
It's a
space
physical.
is collected.
It is a collection physically exists, which all the upcoming data what you are entering in the Mongo, whatever is writing into journal, it is writing also in another copy in the uplog. How
Good.
voting will happen? Good question. This is very good question. See, you have a tree node, good enough. You don't have a choice that one arbiter to one data node, and this goes down, this will pick up automatically because this has the data. This has the data. This is only eligible to become a primary in 3-node replica. 99% only three node replica. No one will follow the 5-node replica kind of. If someone is really have that kind of architecture, what happens? Example, one arbiter, 4 data nodes. Let's talk about this situation quickly. You have 5 nodes, as he is asked how the voting can happen. In 3-node replica, the voting only between the two, I mean the primary secondary role can only happen between the two only. So whatever the servers are available, they can vote because they joined as a member. It knows internally MongoD to MongoD polling will happen every 5 milliseconds. 5 milliseconds is too less. We'll see that 5 milliseconds, 10 seconds, not 5 milliseconds, 10 seconds it will poll basically. 5 seconds, but 10 seconds it will do the failover. So this is arbiter assume case. This is a data node, primary data node. This is a secondary. This is a secondary. This is secondary. If this is gone down, it got the 4 votes. It will sustain. If this is also gone down, okay. Take it other way. So this is a primary, and this is arbiter. Primary gone down. There are 3 secondaries, which should become a primary now, because there are 4 voting, which can form the primary role out of these 3 secondaries, right? So whichever is immediately hop, network hop, this is the nearest hop, means nearest IP in the next IP range. This is holding the next immediate IP, and it is keeping the most recent data out of all. Two things will be checked when before one become a primary in the background. One is recent data, first data validity. It will take check for the data, whichever the member has the next microsecond recent data with the primary immediate data. If this is qualifying with the data, there is no hop eligibility. If all have the recent data, because of all are sitting in the same data center, then it will look for the network hop. What is the next immediate IP hop is coming, that will become a primary. Two cases will followed. One is data recently, whichever has the very latest data with the primary, whichever got synced with the latest data primary, that is the first thing. If all are got the same data, because all are in the same data center, next thing is next immediate IP. It can be. whichever has the next immediate IP, it will pick up. Two conditions will be validated. And if it is the same data center, assume case if it is the same data center, maybe this got delayed, few microseconds, though it is a second immediate hop, but it has some delay for some reason. It will go to the next node as a primary automatically. That is a fully internal mechanism. Anyway, you keep it a remote one. For some reason, local one is actually not syncing well because it is has some network fluctuations. It has some microseconds data. It will go and pick up the remote somewhere. It is some far miles away. Still, it will become a primary because the local one is not holding all the data because of fluctuations. Okay, so it look for the data recent availability and next network hub. Two conditions. Any of those valid, then it will pick up. And not first data, then network hop. So let's come to the module.
And
If
is
you
it
still have
mandatory to
questions,
have everything of the same configuration? Same number of.
absolutely same MongoD and same data disk in both the one. It is if it is arbiter, everything is same, identical. That's it. Single word. Identical means in terms of operating system, in terms of Mongo version, in terms of data drives structure, and everything should be identical to operate well. And memory, CPU, and everything. So why memory? Secondary, you don't do too much, but why you need? Because it can fail over here. When it is fail over, if you don't have a similar system power, then it will not give the same performance. So both should be identical. This is something. If example, I have a 2 TB data, assume a case, 2 TB data. For 2 TB data, at least 400 GB is recommended in Mongo. I'll talk about memory management separately. We'll talk about that. Here 2 TB data and you have 32 CPUs, assume a case. Here also 32 CPUs, 2 TB RAM. It's mandatory. So third node, why we don't keep as a data node generally? Because of to save the infrastructure. Here also 2 CPUs and 400 GB RAM is not something, is a huge cost to the company. That is the reason I'll run this one with the 3 GB RAM, 1 CPU. Still it works. 1 CPU, 3 GB RAM is enough. Just it is a MongoD, just outing it does not do anything. Outing it. So if it does not need the data 2 TB storage, it does not need the memory and CPU also. Just need the MongoDB to run. That's it. Nothing else it wanted. But it should be on the same version. All should be sit on the same version. Is it clear?
Yes,
Say
yes,
something.
Ravi.
Good enough. So let's move on. Replication, guys. See, replication provides redundancy and increase the data availability. That is the intention of the high availabilities. You wanted to keep the redundant data in case of disaster. One node goes down, other node should pick up the load to keep the availability of the data, increase the availability of the data. Replication also allows you to recover from the hardware failure and service interruptions. Whatever the reason the node goes down, other node will pick up. It can be hardware or software, whatever it is. You have a data resiliency in that direction. Some cases you can use replication to increase the read capacity. This is something good. You are using only writes here. You can only read from here. You mention its connection level. When they read intent, there is something extra function we have. Read intent is secondary. The connection automatically will hit the secondary and read the data from secondary. They have to mention in the connection when they're trying to talk to the server. We have that in the next slides, no need to worry. So clients have the ability to send the read-write operation to different servers. Reads to one server, writes to one server. You mention when you're doing it. You can also maintain the copies in different data centers to increase the locality and availability of data for the distributed applications. Maybe this is also data set. This is one data center because it's a local, and I'm keeping this in a different data center and sending all of the data, and all reporting will happen from here. All reporting. All business is going on here, but at the end of the day, reporting is running on the remote secondary server. Both the servers no need to be in the same region. See, I have done lot of migrations recently from one data center to other data center within the cloud, even in the on-premise also, because one of our client data center lease was over and is charging too much. You wanted to migrate to new data center. We did seamlessly in 3 or 4 months. It took 3.5 months basically. We targeted very rigorously because lease is over. if we stay more and more, they're actually charging more and more for, because we did not renew the license with them. Anyway, so I'll talk about how do we migrate using the replica set. This is the best technology to do the migration, upgradation, everything. Everything is seamless. Application don't see the downtime. Without the downtime, you can achieve the upgrades, even migrations, both with the help of replica sets. All right, you can keep one copy in the remote region, and primary region used for the writes, remote region used for the reporting per data locality, because in the remote region they want the reporting, so we are keeping one node in the remote region, data is replicating there and pulling the reports from there. With the additional copies of data, you can dedicate to one to disaster recovery, one for reporting, one or backup. So I wanted to read from this one, and I wanted this one as a DR only all the time. So I wanted this only for writes as a primary it is. You can see it is something you're calling the physical name, it will talk to the physical name. If failure happens, again you need to know the secondary and then call the data from there. Remote region only for the DR purpose. We are keeping it. In case of the whole primary disaster, the complete data center is gone, you still have the data in the remote region. That way it is going to help you out. See, actually before 2.6 something, before we used to call as replica set as master slave replication. This was old name. Master slave replication was the old name of replica set. Now we are calling as replica set from 3.0, I guess 3.0, I'm not sure exactly, but the old name of replica set is master slave replication. It used to be the name, but now we'll call it as a replica set. Okay, so master slave replication also the same thing, one master multiple secondaries. There we'll call it a slave, now we are calling a secondary replica primary replica. This is a word, only wordings are changed. Master slave replication was the old replication mode supported by Mongo. In older version of Mongo, this mode was used for backup, failover, and scaling. There also purpose is same, the names are different. That's it, nothing else. However, master slave replication provides less redundancy, does not automatic failover. Oh, we did not have automatic failover. Maybe I did not work with the 1.6, 1.0 kind of thing. When I started, the servers were running 3.0, 2.6 also have seen 2.6 servers, but very limited time. They migrated to 2.2, 3.6, and 3 2.C. Most of the servers I supported on the White Tiger engine. MF even I did not work much, because 3.2 was introduced long ago. 3.2 introduced long ago, 2014 around, I guess. If you wanted me to check quickly, we can check it off. I'm not sure. Come on, where is this? Mongo version support. Let's go with the Mongo. Maybe this will give the better thing. I mean, dates also will give you when it started, I feel. Come on, does not give. Somewhere I showed you guys. All right, this is the one. All right, if you see when 3.2 was released, 3.2, 2015, I started roughly 5 years ago. So this 3.2, 3.0, 3.0 White Tiger was introduced. I worked most of my career with the White Tiger itself. MAP even has a lot of limitations and drawbacks, and all that was the discussion when I started. But most of the 2.6 I have seen. 2.4 I never seen in my career working on that one. Basically, 2.6 I have seen working on that one. 3.0 we used to do the storage migrations, not the version migrations. Like 3.0 was running on the MAP V1. We migrated the data from MAP V1 to storage engine. That I do remember that part. We did only the storage engine migration, not the version migration. I would have had those documents, I guess. I definitely would have had. I need to check. But how we do the storage migration is a separate topic. I mean, that is no more valid anymore. Why? Because you are on the top one. It is like more than 6 years back. What I'm trying to say. We did a storage migration because mmap v1 was not scaling well, and White Tiger was introduced that time, and White Tiger was giving a lot of benefits. So client asked us to plan for the storage migration. We did on a lot of servers storage migration in the Mongo from mmap v1 to white tiger storage that we performed, that I remember still. But 2.6 was having some issues, and I did not explore much the lower than that. Maybe that time this could be the case. There is an automatic failover kind of, could be. Sorry. MongoDB supports replication with another concept called replica set. This is a new term. Replica set provides the functionality of master slave deployment. Internally, it is following the same thing, except the automatic failover names and all. Replica sets are also more robust for production use. This can handle any amount of data as long as your system is capable of as a standalone. If more and more data, definitely go for the sharding to distribute the data. Replica set. A replica set is a group of MongoDB instances that host the same data, absolutely same data everywhere. Whatever you keep is the data node. One MongoDB primary receives all the write operations, irrespective of number of nodes. 15 nodes you can form in a single replica set. Only one writable, the rest are all readable. And you have 50 means 50 does not involve voting. Only 7 nodes can vote at a time. You are keeping 10 Mongo instances, only 7 can vote. 10 cannot vote. The voting only can happen between 7 nodes only. 50 cannot involve into the voting. That is also one more point you need to keep in mind. One MongoDB, the primary receives all write operations. All other instances, secondary applies the operation from primary so that they have the same data set. That's what primary will go through the oplog. Oplog to oplog data will sync, and secondary will get updated. The primary accepts all the write.
Sorry. So basically, if the 7 servers are participating in the replication and 4 of them will be eligible, so what happens with the other 3 servers?
See, first 7 servers will involve into voting. 7 servers. Okay,
Right.
like you have 7 servers can pick up any server having the recent data, they'll become a primary. 7 nodes here. This is primary, these are all secondary assume case. If this goes down, any of this one can become a primary out of all.
Right.
So you have keep more and more, the more and more will just stand by. If these 7 also gone down, this will pick up the set again to involve in the voting. If it is going, like you don't keep this many. I never seen, just only the theoretical discussion. In the real time, nobody implement that many redundant data. That impossible because infrastructure cost is also involved in the background. So 7 nodes only can vote. Even you go beyond that configuration, that is a limitation of voting. If this first set is gone, anyway you have further node, though they will vote. If the vote is off more than off, then it will form the primary. But at a time only 7 nodes can vote.
So in case if it does not meet its requirements of having 4 servers available, then that means it will consider that the server is offline or something like that.
Yeah, if it is not reaching, it is polling internally. When you add a member, it is polling internally and checking which nodes are available, which node is down actually, how many nodes I have. I can hold the primary role, or I cannot hold it. Primary is always checking the server, secondary servers voting all the time. Every 5 seconds it will check internally. Every 5 seconds polling happen in the background. All right, we'll see that. We have the text also, I kept it. So the primary accepts all the write operations from clients. Replica can only one primary can become out of all the replica set. Replica sets provide the strict consistency for all read from the primary. Primary will have the latest data. Secondary may have some delay, depends on the secondary server capability, secondary server bandwidth, primary to secondary server between the bandwidth availability, all matters. It can be 100% synced or not synced. By default, it is asynchronous. Replica set follow the asynchronous. If you wanted to make it synchronous, we can go with the write concern. Write concern, you add it in the your write operation. But by default, we cannot enforce it is synchronous by default. We're going to talk about that by the end of the discussion. We have that. Replica set, guys. This is, yeah, go ahead, please.
So we cannot have active replica?
No.
Where it keeps writing to both servers?
Only one. Only one is a writable. All secondaries are readable. No active.
Okay.
In Mongo, only one writable, the rest are all readable. Active is not there. Right. So replica set. Replica set provides strict consistency for reads from the primary. Primary will hold all the data to read. You will read the latest up to the point. To support replication, primary logs changes to its data sets in the op log file. The secondary replica, the secondaries replicate the primary's op log and apply the operation to their data set. That is what I said. The data will go to the secondaries through the op log only. That is what the statement is saying. The secondaries replicate the primary's log file and apply the operation to the data sets. Secondaries apply the operation from the primary asynchronously. There is no synchronous. This is also a point I already made. If the primary is unavailable, replica set will elect the primary to become a primary based on the number of votes it receives. It can become a primary. It cannot become a primary based on the number of votes. More than off. If you are receiving the votes, your one of the node will become primary. If not, no. Oblog. The record of operations kept by the master called oblog. Oblog short form is full form is operation log. Oblog will call it as op, but oblog in term is called as operations log basically. Oblog is stored in the special database called local, and we're going to see that. Don't worry, it will create in the local itself, and we can read it. This collection capped collection that I said, and I was talking about this capacity also, right? Where it was, I was showing the capacity of the right here, 990 MB of the 5% of the data disk space. Minimum is 990 MB if it is not qualifying. If it is qualifying, then 990 MB it will start. It can go up to 50 GB maximum. Each document in the oblog represents a single operation. Every operation will record as an independent entry in the oblog. You're writing one write command to command, it will record. Command, if you're running a command, the same command will reflect, and the same command will go and reflect on the target also. We'll see. I mean, I'm going
So
to show that.
sorry. So basically the data comes from the application to the memory, and from memory to the journal, and then journal to oblog, or from memory to oblog?
Memory to oblog. Journal to oblog is not there. It simultaneous writes to the oblog and journal both.
Oh, okay. So
It's simultaneous. Oblog is that stores only operation that change the state of the database. If you are reading, no entries in the oblog. Only modifications will go into the oblog. As simple as it is. Right. Automatic failover. When a primary does not communicate with other members of the set for more than 10 seconds, failover will happen. 10 seconds, like it is given 10 seconds time. Primary is actually, like current primaries failed. Second primaries to elect secondary to become primary takes 10 seconds in the background. 10 seconds time to pick up the role and start giving the response as a primary, basically. If something goes also, it will take 10 minutes to detect and do the failover as well. So failover threshold is 10 seconds. If someone asking you what is the Mongo failover threshold is 10 seconds. This is what you have to say. The replica set will attempt to elect another member to become a new primary. The first secondary that receives the majority of the votes become the primary. Majority of the votes based on the recent data, based on the next hop immediately. Next IP, which can immediately available. Two things it will consider. First data, recent data. Next is next hop. These two things validated, and primary, one of the secondary will become a primary based on that. Replica set members. A replica set in MongoDB group of MongoDB process. It's a group of MongoDB process that provides the redundancy and availability. First slide itself. Primary receives all the write operations. Secondaries replicate operations from the primary to maintain the identical data. Primary is for write only. The secondaries will get the data from primary to keep the identical data. Arbiter, what it does, it just only vote. It does not do anything. That is I picked up. Arbiter is required just to vote to become one of the secondary to be primary. If not, the secondary will remain secondary only. Arbiters do not keep the copy of the data. However, arbiters play a role in the election that elect the primary if the current primary is unavailable. Only voting purpose we keep the arbiter. One primary data node, one secondary data node. This is only arbiter with the lowest configuration I discussed, right? You have a 2 TB, 400 GB RAM, 32 CPUs, but here 3 GB or 1 CPU is enough. That way it is, just voting node. Starting from 3.0, a replica set can have up to right. This is 3.0. Okay, I did not remember when it is introduced 50 members. This is something good. From 3.0, you have a 50-member replica set, but only 7 members can vote to elect the primary. This is the statement I was making all the time. 50 members, but 7 only can vote at a time. Whatever is there in the group, 7 members can vote. 7 within that, the election will form and the new primary will be elected. If you have more than that, some servers are keep down, other server will pick up the role anyway. But at the same time, 7 members can vote it, not more than that. Right, this is the situation, guys. Type of replications we have. I'm going to show everything. What I'm talking here, what I'm going to show practically. It's not just a theory at all. Just have things in mind. I'm going to pick up every type of replication. We have a lot of different type of different secondary members. For different purpose, we configure it, basically. Priority 0 replica set member. See, when you have 3 replica set, and in the remote region you have a data dependency because they are generating the reports. So now I'll keep the member priority to 0. We can keep it in the config file. How do we build the config file? How do we change the config file on the fly? We will see that in the course itself. For now, 2 servers in data center 1, 1 server in data center 2. This server is always required for the reporting. They are fully dependent on this one, but it never should become a primary. Even in the case of primary failure, it should become a primary all the time. Even, example, these 2 servers are gone, it will remain secondary only. If one of the server is available here, it will become a primary because this can vote. This will form the vote, but it cannot become a primary at all. Why? Because you don't want to make it a primary. It is remote region. It is a remote region where you never want to. If primary goes down, this will become primary. If this is also gone, this will remain secondary only. Whenever one of the server comes online, it will become automatic primary again. So primary, you wanted to keep the role in the primary data center only all the time. Then primary 0 replica set member can be configured. We will see this. We'll see this. I'm going to show this clearly. I'll do the failover. It only switch between these 2 nodes. You never touch this one. Even it no need to be in the remote region. Just configuration is enough. Priority 0 you're mentioning means don't go to that. As simple as this.
I have a question, Ravi.
Yeah, go ahead.
Replicated node shouldn't be on a different data center than one, because
It can be anywhere.
yeah, because if one data center goes down, then both primary and secondaries are going to go down.
Okay, you're talking about the whole data centers, then it's a very big disaster. Anyway, you have the data. This one you can make it a primary forcibly if you wanted manually.
But practically, it shouldn't be like way around, like primary, secondary on the data centers too should become primary in case of failure of primary.
No. See, data center case, you're taking about worst case situation. The whole data center is down and you are fully dependent on secondary only to operate with the data. You can make this primary at force command. We have force command to make the secondary also a primary. That something is the last option. We will call it off. But as long as it is in, like in West US, it's in East US. You wanted to make the data because from here people are pulling the reports. This is also work as a disaster recovery as well. You don't think like complete data center at one go it is going down. Maybe it is like once in a blue moon kind of. You may not see in your lifetime. It can. So as long as this is available, work from here only. In a worst case, I'll make this primary manually.
Mm-hmm.
It is like
No,
that.
like
I think my past experience, I had 2 incidents, like data center completely went down. One was due to storage and one was due to network issue. So that's why I was thinking about having a secondary which should become primary on a different data center rather than on the same.
Right. See, this you have control. This can become a primary because all the time that can be a, once in a while in a lifetime. It's going whole data center down, not all the time. So if this is gone down anyway, we can make this secondary with a force command.
Mm-hmm. Got it.
That something is intentional because situation is demanding it. We have to be flexible enough. It does that. So, but anyway, as long as this is primary, this primary data center is up and running, this is only the primary. If this is gone down, it still says secondary. And if you really want to operate from there, we can make it primary manually. How do we do it? Is the course, again, the practical part.
Mhm.
Priority member is a secondary. Santosh, you were asking. Sorry, you can go ahead if you have the question still.
Yeah, no, I think Biryan question was in general, like RDMS, generally we have primary and secondary, where primary will be in one data center and secondary will be in another data center. Typically in RDMS, right?
Right,
So,
right.
but
But
whereas
here
here, I think, yeah,
we are taking the advantage of two nodes, minimum one data, one primary data, and secondary data is also mandatory. So here we are taking this advantage to keep the local primary write copy. You don't keep the remote copy it remotely and then operate. Performance delays will be there. So it
this
is
is more of a HA concept. Yeah,
intentional call.
We are giving more HA concept than DR. I mean, like more HA availability is more.
Right, that's correct. Priority member is a secondary that cannot become primary. Priority member can trigger the election. It can form the voting. Priority member 0 can maintain a copy of the data set, absolutely all the data, accept read operations and votes in election. Priority member is useful in multi-data center deployments. This is the case. In a 3-member replica set, one data center hosts the primary and the secondary data center will host the secondary of with the priority 0 member that cannot become a primary. Priority 0 member can function as a standby all the time, as a data recovery as well as reporting. Both you can take the advantage of it. Next, hidden replica. This another big thing. Hidden replica. Hidden replica, even you cannot read remotely. I have a machine. Let me explain this with a new notepad. I never seen this anyway, but you need to know. We can configure it. I'll show it off. You have one primary, one secondary, and one hidden within the data center. Assume again. Hidden data will sync all the data. Good enough. But you have an application server. Application server cannot hit this. You wanted to call this Mongo. You wanted to pick up the data out of it. You had to call from the local application only and then read the data. Data is absolutely readable from the local copy, but not remote. Hidden will be designed for only backups. You wanted to generate only backups on this one, keep the hidden and then keep it dedicated for only backups, no other purpose with that. Or else you have a reporting services, you're running locally and pulling it off and sending it to someone. Okay, that also will be fine in the hidden concept. But hidden MongoD equally receives the data and it is not remotely detectable. Remote connections cannot be accepted on the hidden Mongo replica node, secondary replica node. And hidden cannot become a primary because remote connections cannot hit it. So if you want it to become a hidden, first make it priority 0, then hidden. Two conditions must be given. It should be priority 0, should not become primary, and hidden. Both should be true. Hidden, there are two properties we have, hidden and priority. Both priority should be 0. It should not never become a primary. If it becomes a primary, applications, all connections will break. It cannot accept the remote connections. That is first thing is priority 0. Then hidden means you cannot read remotely. Only locally you can read it. This is only dedicated for the backups. Only I never seen in my whole career configuring a MongoDB as a hidden node, but it is there. You need to know what exactly it is a purpose behind. Any question? Okay. So hidden member maintains a copy of a primary data, but it is invisible to client application. It is not remotely connect. It cannot connect remotely, as simple as it is. Hidden members are good for workloads with the different usage patterns from the other member replica sets. Basically, hidden members must always be priority 0 member and so cannot become a primary. This is what I was saying. Hidden members, however, may vote in election. Use hidden members for dedicated tasks such as reporting and backups. You wanted to run the reporting locally, then use hidden. You wanted to use that node completely for the backup set, use it, because backup sets run in the backup local machine itself. I mean, it trigger in the local machine. In the following 5-member replica set, all 4 secondary members will have the copies of the primary data set, but one of the secondary member is hidden. This is hidden, and this is absolutely priority 0 and hidden. These should be true. And if these two should be true, it can only read within the machine. Remote connections cannot be made, and you have to run anything on that one with the local application. Install the local application, call the data, and whatever you want it to do. It's for the dedicated action. I never seen personally you implementing this, but knowing is important thing. Delayed, this is something we have used this thing especially. Let's talk about. See guys, this is very, very important. Delayed replica is important to know because this is implemented, I've seen as well. This is a primary, this is a secondary, this is also another secondary. So I'm delaying a 1 hour here data, 1 hour delay or 2 hours delay, maximum 3 hours will go with. I never seen more than that. Depends on the oplog capability. We had talked about this is a journal, this is a data, and this is oplog. Oplog will come with a particular size. This size, how many hours it can hold the data based on the number of transactions hitting that at that moment. It all matters. But there is a command. If you run that command, it will tell you that based on the number of transactions coming to the log file, it will tell you that these many hours this log can hold the data. It will give a rough estimation. There is a command. If you query that command, it will tell you that based on the current rate of transaction, the oplog is capable of holding these many hours data. These many hours data it can hold based on number of transactions based on the current size of the log file. This is an estimator command. It will tell you the clear time. This many hours data oplog is holding. If you hit more transactions, it will tell you lesser time. If you less transactions, more time it will display automatically. It will detect automatically live transactions and give you the estimation time it can hold. So basically, at least 22 hours to 1 day data oplog will maintain. That's how it will be designed. Okay. If you are 1 TB data, 50 GB log is something is a operation to operation basically. So Mongo is not something you write every second. They do load the data at one time, and the rest of the time it will be free or minimal transactions basically. Anyway, the thing is, we wanted to keep delayed replica. A delayed replica, if someone is deleted a database here, someone deleted accidentally, the database deletion also will happen in the secondary. What we do, exact thing will happen in the secondaries. But I kept 3 hours delayed. 3 hours after whatever you do here, it reflect here after 3 hours. Because we are intentionally delaying the time. We will mention the time. So if I do a mistake here, I can recover within 3 hours here from here. That is the only intention, delayed replica. For bad operations, we wanted to recover out of that bad operation from the delayed replica. That is the only intention, nothing else. Any questions, let me know. Questions? If not, let's go to the slide.
In that case, you need to stop the primary first, right? Because
No,
primary is
no. We don't stop. Everything is on. You deleted database. You realized within 1 hour there are 3 hours delayed replica. If I delete here, it will delete immediately here. It is not delayed, but this is delayed. It will be there for next 3 hours. All the data. So you pick up the dump from here before it deletes here, and then restore it here again. Primary recovery, data recovery.
Got it.
So in Mongo, you have only full backup. There is no differential, no logs, nothing. Replica said you have log backup called oplog backup. We have it. Okay, we'll see that. But there is no differential backup. Mongo, in terms of recovery, RDBM is so sophisticated in terms of recovery. Mongo is not sophisticated. There are recovery challenges we have with the Mongo. I'm going to talk about that in this module and the backup restore also, both recovery challenges. Anyway,
They,
delayed member. Go
sorry,
ahead.
like I know, like MongoDB is used for more of NoSQL. So you're saying there's no log backup. I mean, like hourly backup or
Oplog. We have hourly backup from the oplog.
not from
We
the
can take
database.
it. If it is standalone, there is no oplog backup or nothing. Only full dump all the time. You don't take full dump every 1 hour, right? Only once in a day. So you are compromising 1 day data. So that is the reason all productions will operate with the replica set. So minimum.
Okay.
All productions will operate with production to protect the data because standalone does not give you the recovery points. Replica set can give you the recovery points. We'll see that.
Sure. Yeah, got it.
Delayed members contain the copy of the replica set data. Obviously, delayed members data set reflect an earlier delayed state of the data set. Basically, delayed means obviously we are mentioning a time based on the pickup. We can read how long it is delayed when we have a command, guys. For everything we have a command. How long is the second is absolutely in sync, or how many minutes behind it. So how delayed replica, how the secondaries are getting delayed to get the data, everything we can monitor. We have all monitoring commands. We're going to show that. A delayed member can make it possible to recover unsuccessful application upgrades or operations errors, including dropped database or collections. Anything you do on the primary by mistake, you can recover from the secondary before it reflects, before it happens on the secondary, on the delayed replica. A delayed replica should not become a primary again, because always it operates with the data gap, some hours gap. So it should become with the priority 0 first, then delayed. We have to mention the time. Delayed members apply operations from the oplog on a delay. How it up, we can see how much delay it is behind. Based on the time you mention, it will mention the same thing. We'll see that. Consider that amount of delay must be equal to greater than your maintenance window. Maintenance window means your oplog window. Oplog window is just having 1 hour, you're keeping 3 hours, you're gone. It will at least generally it will keep to 20 to 22 hours data. That's how we design. 20 to 22 hours data, then it'll keeping 3 hours, no harm. It should not be closed. Like it has a 6 hours data, you're keeping 3 hours. At time you are loading a lot of data, it is flushed before 3 hours, then this will not sync up anymore. So at least it has to sustain that long, whatever you delay you keep it, the oplog. That is, it must not be it must be smaller than the capacity of the oplog. Smaller the oplog is more, and the delay should be lesser all the time. Next, delayed replica configuration. This is something, how do you do it when we start itself? I'm going to tell. This is when we don't understand. Priority, hidden, slave delay, everything must be true. Why this? We'll see that. The following example set 1 hour delay, and the second 3600 seconds equivalent to 1 hour. Second, remember currently at the index 0 member array, the delay, the set the delay, issue the following sequence of, no need to worry, I'll skip this, I'll show practically. Right, this is what I was talking. This is what exactly I was talking. This is, anyway, we are done, guys. This is so simple slides anyway. Just let me take a little 5 minutes extra. Write concerns. These write concerns comes from the application. You cannot define at the back end. Write concern describe the guarantee that MongoDB provides the reporting on the success of the operation. If you are writing, you wanted to write in the primary only, you wanted to write on secondary also get the acknowledgement, you wanted to do the acknowledgement from memory itself, journal itself. We have a lot of things, guys. How they want it, they have to define it. With the stronger write concerns, client wait for the sending write operation from the MongoDB to confirm. So before I come to this, let's come to this one. These 12, then I'll come to this. See, there are unacknowledged, acknowledged, journal, and replica acknowledged. There are 4 write types of concerns we have. Write concerns are 4. Unacknowledged, they had to write the concern like this. They mention the write concern. See, when they mention this, majority timeout. So W is something write concern. They'll have to mention in the connection when they're passing it. So what happens? Try to understand. Unacknowledged. With unacknowledged write concern, MongoDB does not acknowledge the receipt of the operation. Unacknowledged similar to error ignored. See, you submitted an action, you never get the response. In the background, it could have been failed, it could have been successful. We don't know. You never get the response from the Mongo at all. You just unacknowledge me, just submit the action, let it happen. It don't happen, I don't care. Just don't give me acknowledgement. Just you submit. It is either passed or failed, whatever it is you don't want. That is called unacknowledged. No one will use this. Even pre-prod also, they need some confirmation whether the transaction is finished, not finished, kind of. Acknowledged is something what it done, either it is successful or not successful. You'll get the message. At least you're running update you're trying to update which does not exist a record, or it does not the collection itself does not exist, you're trying to update. You need to get some message like these many records are modified. You have seen that when I'm inserting it, these many inserts are record happen. When I'm updating, these many updates are happening. It will give in the output, it will give acknowledgement like that message. So you need an acknowledgement. with the receipt of acknowledgement write consent, MongoDB confirms that it received the write operation and applied the change in the memory in view of the data. See, the driver is giving the command to the MongoDB. MongoDB is responding back. Here there is no reply. There is no reply, success or unsuccessful. It doesn't know. It does not care about it, giving the acknowledgement to the application again. Here it definitely gives the acknowledgement. Okay, either you failed or successful. You get the message. And journal, this is something that is very important. That is what we are talking about. Journal all the time. Journal, then go to the application. This is called default. Sorry guys. Sorry. Journal. With a journal write concern, MongoDB acknowledges the write operation only after committing the data to journal. This is what exactly I was making a point. You are writing the data and data from the memory is written to a journal, then application will get the response. If it is failed, from the memory itself will respond. It does not go to the journal because it is failed. But if it is committed, it has to write in the journal, go to the application. This is the default MongoDB acknowledgement model. This is what by default will happen. But this is what they have to mention if they want it. They don't want this, they can mention this in the connection string. Now, if you come to here, replica acknowledged. It has to commit in the primary, write into the journal, and go to the secondary. See here, writing it, apply here, it will write into the journal, go to the secondary, apply in the secondary, then come back and give the response. You're giving the replica, one of the replica must be applied with the transaction. You keep, 0 means here memory acknowledgement, write concern, 1 means journal acknowledgement, 2 means replica, 1 replica acknowledgement, 3, maximum 3 only, 2 replicas should be acknowledged. I mean, it is written in the primary, it went to the secondary also, 2 secondaries are written, they acknowledge to the primary acknowledgement to the application. It is too lengthy operation. You're delaying the action by giving the more write concern. Data is guaranteed that in the background it is written in synchronous, but you see the lot of blocking. Why? Because you're locking the collection data for longer time for getting the acknowledgement, but that time the collection is locked, other people are going into the blocking. More concern, write concern, more blockings. Why? Because the longer the keep the lock, more blockings will happen. So this is not good advisable. Generally they should go the journal acknowledged only, generally. But if they wanted they're doing very critical data operation, they want it to be replicated, they can mention it. The blocking can happen, but the intentional activity that is fine. Let's come back to this one now. With stronger write concern, client wait for after sending the write operation to MongoDB to confirm the write operations. When insert, update, deletions have a weak concern, operations runs quickly. They don't need to go on secondaries and verify or write into the journal and then verify. Just memory it will give the acknowledgement. The weaker the concern, the quicker the action. MongoDB provides different levels of write concern to better address the specific needs of the application. Clients may adjust the write concern to ensure that most important operation persists successfully in an entire MongoDB deployment. So it is critical. You wanted to get the acknowledgement, then only you wanted to commit, then mention it in the operation itself. For the less critical application, client adjusts the write concern to ensure that faster performance than the endure persistence to the entire deployment. You don't need the performance. Don't go with higher concern. If you wanted the performance, you don't need the performance. You wanted the guaranteed data in all the secondaries also. Go for the higher. It is up to the requirement. You cannot define that. Default write concern is actually general acknowledged, right? That we talked about. Now modifying the write concerns. Basically, when you give the majority here, there should be timeout. See here, timeout is given. 500 milliseconds means 5 seconds. It will try to update the secondary 5 seconds. If 5 seconds the secondary is not responding, then skip that majority and then go with the acknowledgement. If you don't mention this, it will go in the infinite loop. It will wait for writing the secondary. If it is not writing, it will fail because you are not handling the timeout. You must handle the timeout when you go for the replica set acknowledged, or else you go for any other acknowledgement which is not default. You have to give the timeout. So that must be, if not, they are gone. This is what exactly I was talking about. Replication blocking. MongoDB get lost error command allows developers to enforce the guarantee how up to data replication is updating write concern. See, Here we run the get last error will block until see here. We run the get last error that will block until at least n servers have replicated last write operation. So we are sending that, we are telling that these many write consents number is saying that how many servers you wanted to replicate before I get the acknowledgement. Primary itself are one secondary or two secondaries, maximum two secondaries you can tell. 3 is a maximum, 0 is memory acknowledged, 1 is a journal acknowledged, 2 is a one replica set acknowledged, 3 is a two replica set acknowledged. So if n is 2, the master won't respond to the command until at least one slave has a replicated data lost operation. See, replication happens basically. The more write consent, the more blockings will happen. Basically, you are locking the particular data segment or collection, whatever it is, for longer time. When you are longer time placing the lock, other people go into the queue. The queue itself is a blocking. Following or not following? Say something. This is important.
Yeah, following.
Right. When specifying the get last error takes additional parameters, timeout, which is a timeout of blocking for replication, will cause the write consents here. Blocking for the replication will cause the write operation to slow down significantly, particularly for large values of. So more value you give it here, like it start with 0, 1, 2, 3. The more value, the more weight, more blocking. As simple as it is. You don't maintain it. It is from the application itself. Read write concerns. This is what I was talking again. When you have a 3 members, which one to read? Which one means you wanted to read from secondary or primary itself? We can mention that in the connection string. We have all the things. Use the read concern option to specify you wanted to read from the local or replica set member or what you wanted to read. To specify the read concern at Mongo shell level, db.collection and read concern, they have to mention extra cursor. Read concern dot read concern, what level? Primary you wanted to read or secondary you wanted to read, where you wanted to read, or majority of the secondaries you wanted to verify. See, read concern are multiple levels again. Let me come to this and then come back this. Prefer, see, primary preferred for read preferences here. Primary preferred means I want to read from the primary only. Prefer secondary. Prefer secondary means only secondary. If secondary is available, then only read it. Else don't read it. Secondary preferred. Secondary preferred means secondary is available, read from secondary. If secondary is not available, read from primary. Preferred is something different. Only secondary is different. If I'm keeping primary preferred, guys, I can read from primary. If primary is down, secondary, there is no primary at all because voting is not happened. Secondary is available, go and read, because preferred means that in some situations operations read from the primary, but if primary is unavailable, read from secondary member. Secondary only means all operations read from secondary member only. If secondary is not available, don't read it. It will not read. Anyway, secondary definitely will be available at any point of time in Mongo. Primary may not available, but secondary will be available. Second preferred, in most situations operations read from secondary members, but if no secondary members are available, operations read from the primary. Okay. Nearest means if my application, there are multiple secondary nodes, I wanted to hit the nearest secondary server to get the data. I never seen this nearest one, but anyway, operations read from the members of a replica set with the least network latency, nearest one. Let's come back to here again. This one. So locality, see here, read concern local means the you have a read concern, one level is a primary or secondary. Read concern local or majority. Local means whatever the member you are trying to read, it can be secondary or memory, whatever the data is available on the local machine, get it. I don't care about what is there, just local on which machine I'm trying to read. Majority is something, it will read from the secondary only, but it will check for 2 or 3 secondary members. I'm reading one secondary, other secondary also have the same data or not. It is checking it, then it is reading it. Comparing the secondary server's data, whatever is the latest data it has, it will pick up from there. It is a too tricky discussion anyway. You just keep in mind. That's it. Nothing else you have to carry from this. Why? Because you never handle this.
In this case, we have primary and secondary, and third is just a kind of witness. So it is going to compare with the primary.
Yes. In this case, if you have only one secondary, there is no comparison. Primary it won't go. Only secondaries only. all secondaries, wherever all secondaries have the, I'm reading from one secondary, you have one more secondary, then this secondary is having the latest data, other secondary having the data. It will compare both. Wherever more recent data, it will read from there. So compare and read.
So practically, as you said, that it's going to be 3 node replication. So this scenario is never going to happen.
Right. So it won't happen majority, only on the local itself. Even you apply, it is local only because only one secondary is available. It does not compare the primary. If it compares primary, always primary will hold the latest data. So there is no meaning in it. So it won't go to the primary, only secondaries it will inquire. Multiple secondaries, then this will make sense, majority. So next, read preferences. How do they mention it? Actually, when they're reading it, they'll keep this mongo.set read preference to set the read operations. And see, read preferences describe how MongoDB clients route read operation to the members of the replica set, which member you wanted to read from. By default, an operation directs to the primary only. By default, primary, all the cases. But you have to mention that what you wanted to read, from where you wanted to read from the application side. It's not our job. For an application does not require fully up-to-date data, can improve the read throughput or reduce the latency on by distributing some of the read to the secondaries members of the replica set. So you wanted to redirect secondaries, the read operations, writes to the primary. So you are distributing the load. So it will give a good performance, right? Mongo shell read preference cursor method provides access to the read preferences. They have to mention this basically when they're calling it. A list of modes given in the next slide. This is the one. This is the one we're talking about, right? So I'll finish it, guys. There is nothing much in the further slides. Rollback. Okay, rollback. Rollback we will see during the as a scenario only. I don't talk about this. Deployment studies also I don't talk. Okay, these are all situation. We're done with the theory. Then these are all situational. These are all scenarios. These slides are all scenarios, strategies, and we are going to wanted to change the op log, why we wanted to change the op log, and automatically sync a member. Like one member went out of sync, how do we sync it again, resync completely? We'll see all of that. So till this point, keep in mind the rest will be covered as a scenario. Okay, so we did with the theory part. Tomorrow is absolutely practical. I'll clean all my notes to keep as a plain thing, and then I'll start from the scratch. What I do, I'll build a new node. I'll make it as a, see, we have 3 nodes already. I build one node. I'll delete it. I'll build in front of you all. I'll change the host name. I'll change the IP and everything. I'll make it as another node, and then add it to the replica set. It'll go with the encryption, and it has a lot of interesting configuration. We'll see that tomorrow. Very important class. Any questions before I stop?
Yes. So one question I have, how the licensing differs. So generally in RDBMS, if secondary is like not read only, then you don't get we don't need to pay the license. How works it here?
Right. If it is enterprise, then only licensing will apply here. If it is enterprise standard, you use n number of servers and n amount of RAM or CPUs does not matter to the Mongo company. What matters enterprise? Enterprise, they are charging based on the RAM. How much RAM you are using based on the charge depends on the RAM, not on the CPU, not on anything. How much RAM you're using for the product, based on that they are doing the licensing. Like it is secondary or whatever is you're deploying one replica set, you're using 420 400 GB or 400 GB 800 GB, then you pay that amount for both. For enterprise is costly, and they do the RAM based licensing, not the CPU based.
So the RAM is counted for both the replica set and the primary.
Yes, both. That is where you need to look at which is best option for you. Enterprise or standard is a great data. Okay, I'm getting too much business. I can easily pay it. Then go for the enterprise. No, I cannot afford because this is not generating too much money, but I need the data. In that case, go for the community. So it's a business call. We don't call on that option basically. What data is critical, they know it as a business. We will implement it. We are only the implementers. We are not decision makers. Which community edition or enterprise edition is decided by the business, because which is giving the revenue, which is not giving, they know it. right?
Okay.
Right. Any other question?